Today we are going to talk about solving quadratic equations. But before we start solving them, first we are going to define quadratic equation. We define quadratic equation to be any equation of the form ax squared plus bx plus c equal to 0, where a, b, c are real numbers and a cannot be 0. Because if a is 0, then you have bx plus c, which is a linear equation, and this is not a quadratic anymore. Now, if you look at the exponent of a quadratic equation, the maximum exponent is 2. So this is a degree 2. And since the degree is 2, we can have at most 2 zeros. There is a possibility of having no zeros, or even 1 0 or 2. Now, to see how it can happen, if this is my Cartesian coordinate system, I can have a quadratic which looks like this or this, and you can see there are 2 x-intercepts here, or 2 x-intercepts here, or 2 zeros. You can have a quadratic like this, which just touches the x-axis. You can have only 1 0 on 1 x-intercept. In fact, you have 2, but they are both the same. Or you can have a case like this one or this one, and there is no x-intercepts, or there is no zeros. Now, how do you solve quadratic equation? Is in this section you are going to use factoring. So you are going to do the first one with one example: x squared plus 9x plus 14 equal to 0. As you can see, the leading coefficient is 1, so I can factor this one using sum and product method. Find two numbers, they multiply to 14, and they add up to 9. Those two numbers obviously are 2 and 7, so I can say this is equal to x plus 2 times x plus 7 is equal to 0. Since the product of two numbers is 0, either both of them or at least one of them has to be 0. So if x plus 2 is equal to 0, then I say x is negative 2. I move this to the right. Or x plus 7 is equal to 0. I get x is negative 7. So you can see that there are two solutions, two zeros, two x-intercepts. And as usual, to test it, put it back in the main equation and see if it gives you a 0. The next equation is 2x squared plus 5x is equal to 0. As you can see, I can use the common factor. I can common factor x, so I get 2x plus 5 is equal to 0. It gives me 2 again, two numbers, the product is 0, so individually they have to be 0, so x is equal to 0, or 2x plus 5 is equal to 0, so x is negative 5 over 2. That's the second solution. The next example is 6x squared minus x is equal to 15. So I'm going to first move 15 to the left. I get 6x squared minus x minus 15 is equal to 0. Since the leading coefficient is not equal to 1, I cannot use product and sum. So I use the method finding AC, which is 6 times negative 15, which is negative 90, and b is equal to negative 1. Find two numbers, the product negative 90 and the sum to be negative 1. Those two numbers are 9 and negative 10. 9 times negative 10 gives me negative 90, and 9 plus negative 10 gives me negative 1. So I can write above this one as 6x squared. Instead of negative x, I write 9x plus 9x minus 10x gives me negative x minus 15. Now I take these two and these two together. From the first two, I can factor out 3x, and I get 2x plus 3 minus the second one. I take 5 out, so I get 2x plus 3. Now 2x plus 3 is common, so I factor 2x plus 3 out, and from this guy I get 3x, and from this one I get negative 5 is equal to 0. Again, the product is 0, so one of them has to be 0, so 2x plus 3 is equal to 0. So from here I get x is negative 3 over 2, or 3x minus 5 is equal to 0. From here I get x is 5 over 3. So these are the two x-intercepts, zeros, or solution to 6x squared minus x equal to 15. Now we are going to do the next example. The next example is an application problem. It says that we have a stone which is thrown into ravine is modeled by the equation y is equal to negative x squared plus 5x plus 84. Since leading coefficient is negative, parabola opens downward, so it's going to be something like this. Now x represents the distance which it travels horizontally, and y the distance that it travels vertically. How far does the stone travel horizontally before it hits the water? When it hits the water, because we have chosen x-axis to be on the surface of water, when it hits the water, y is equal to 0. So I have to solve negative x squared plus 5x plus 84 is equal to 0. Now, since the leading coefficient is negative 1, I can multiply everything by negative 1. If I multiply everything by negative 1, I get x squared minus 5x minus 84 is equal to 0. The leading coefficient here is 1, so I can use the sum and product method. I'm going to find two numbers. They multiply to negative 84 and add up to negative 5. These two numbers are 7 and negative 12. 7 times negative 12 is negative 84. 7 minus 12 gives you negative 5. So I can write this equation as x plus 7, x minus 12 is equal to 0. Again, the product is 0, so each one of them has to be 0. So x is negative 7, x is equal to 12. Now, since x is the horizontal distance that the stone has traveled, x equal to negative 7 does not mean anything. So it's not acceptable. But x equal to 12 is the distance which is shown here. Now you may say, what is x minus 7? Remember, your parabola, half of it is drawn here. The other half is going to be something like this one. This negative 7 is this one, which is the other 0 of the parabola. But we don't care about that one. The next problem is about the rectangle which has sides 3x plus 1 and 2x minus 5. Area is 1150. What are the dimensions? By definition, area is 3x plus 1 times 2x minus 5, which is equal to 1150. If I expand this using the arrow method and then move 1150 to the left and simplify, I'm going to get 6x squared minus 13x minus 1155. Now there is no common factor here, and a is not equal to 1. So AC is 6 times negative 1155, which is going to be negative 6930, and B is negative 13. Now we have to find two numbers. The product is negative 6930, and the sum has to be negative 13. Those two numbers are negative 90 and 77. Negative 90 plus 77 is negative 13. Negative 90 times 77 is negative 6930. So I can write this quadratic as 6x squared. Instead of minus 13x, I write as negative 90x plus 77x minus 1155 is equal to 0. Now, these two terms together, I take 6x out, and from here I get x minus 15x, x minus 15, and from the other one I take 77 out, I get x minus 15 again. Now x minus 15 is common, so I get x minus 15, common factor, 6x plus 77 is equal to 0. Now this gives me two solutions. One, x minus 15 is equal to 0, so x is equal to 15. 6x plus 77 is equal to 0, so x is negative 77 over 6. This is not acceptable because the dimension, they can't be negative, so the answer is x is equal to 15. So 3x plus 1 becomes 3 times 15 plus 1 is going to be 45, 46, and 2x minus 5 is going to be 2 times 15 minus 5. 2 times 15 is 30 minus 5 is 25. So the dimensions of the rectangle are 46 and 25.